So, good morning, everyone. Welcome to my YouTube channel. So, in my previous video, we looked at an item in mechanics, that is physics paper 2 O level. Today, I want us to look at electricity, how we can go in electricity while answering the paper 2 items. So, we have our item here. Which goes by, teachers always complain about the presence of fake equipment delivered by some laboratory suppliers across the country. One notable material they have identified is a Constantan wire. A good quality Constantan wire of length 100 centimeter has a resistance between 40 to 8 ohms. It is 4.0 ohms and 80 ohms inclusive. I think I just missed out the units here. Inclusive. Your physics laboratory has some rolls of bare wire labeled Constantan wire. Just verify whether the wire provided is of recommended standard. So now, based on this scenario here, for us to be able to verify this, to verify whether the supplied wires are of recommended standard here, we must come and find the resistance this wire over 100 centimeters. How are we going to do this? Remember that when answering these items here, you must know the theory of the experiment that you are going to do. So before you do anything, we shall begin with some side work and analyze what is going to be done. What is going to be done to come up with the resistance of this what? Of this wire. So basically this one, we shall begin with our equation for EMF. This is sketchwork. We have our E is equal to I into capital R plus small r, where our E is the EMF of the dry cell, then I is the current flowing in the circuit, then R is the resistance of the wire, then small r is the internal resistance of the dry cell. But remember, from the factors affecting resistance, our R is directly proportional to L. So our R is the same as K times L, where K is the resistance per centimeter. So we shall have our E is going to equal to I into KL then plus R. So now our E is going to equal to I KL plus I R. Now we can divide by I on both sides. So that will come up with our E over I is equaling to KL then plus R. So in this case here, we can divide by E so that we can come up with 1 over I is equaling to K over E times L, then plus R times divide by what? Divide by E, where our E is the EMF of the dry cell, I is the current flowing in the circuit, then L is the length of the wire, and smaller r is the internal resistance. Now, if you plot a graph of, in case you plot a graph of 1 over I against L, we shall come up with, it will be in this form, My is equal to mx plus c, whereby our m is the gradient, y, for this case, if you are comparing, our y will be the same as 1 over I, then our x is going to be L, and then our m is the same as the slope, whereby for this case, our slope s is going to equal to k divided by E. So you can come up with the value of K, where K is the resistance per centimeter, which will be slope times our EMF. Now, from this one here, we are able to come up with the resistance per centimeter of that wire. Then we shall have our intercept C is going to be given by R divided by E. So our R is the same as C times E. So you can use this experiment now, this kind of setup here, either to determine internal resistance of the dry cell or to determine resistance per centimeter. And after getting resistance per centimeter, we can use it to come up with the resistance of the wire. After coming up with K, for example, resistance of the wire is going to be given by resistance of a wire of length 100 centimeters is going to equal to 100 times K. This one will give us the resistance in 100 centimeters. So we have already done our analysis here. Now what follows here is going to be now on the answering this item here. We have been just doing an analysis to guide us on what are going to be changing, what are going to be fixing. So now in this case here, we shall be changing the length of the wire. Now you know by increasing the length of the wire or reducing the length of the wire, it will be affecting the current that will be flowing in the circuit. That will be flowing in the circuit. So our independent variable is going to be length of the wire, whereas our dependent variable is going to be I. Then for this case, you also be having a derivative variable, which is going to be 1 over I. So now in this case here, we are assuming, or you are taking our E, which is EMF, we are taking it to be constant. But you shall also be able to determine it with time. Then we go and start the procedure. Now, procedure number 1 here is going to be, okay, the first step is going to be the title of the experiment. Title of the experiment. So you have title. Remember that our title must have aim and must have the purpose. Must have the aim and must have the purpose. Now, for this case here, our aim is going to be determining the resistance of the wire. Determining the resistance of the wire. Now, the purpose is going to be to make a recommendation or to find out whether the supplied constant wire are of recommended standard. That is going to be the purpose. So we have the aim and then the what? The purpose. So we shall come and give our title that an experiment to determine the resistance of the Constantan wire in order to help or to find out whether it is of recommended standard. It is of recommended standard. This is going to be our title. The title must capture the aim. It must also capture the purpose of the experiment. Why are you doing that experiment? Purpose of the experiment. Now, what follows here is supposed to be hypothesis. Hypothesis, I talked about this last time, that the hypothesis is like an estimate, an approximate value of the quantity that you are investigating. So that is our hypothesis. In most cases, this one you can get an idea from the scenario, or sometimes it comes with experience. When you have done very many experience involving the resistance of the Constantan wire, you will be having an idea. So now use that idea now to come up with the hypothesis. So you shall come and say the resistance of the Constantan wire. Constantan snow wire is between 4.0 ohms and 8.0 ohms. That is going to be our hypothesis. I'm just picking it from the what? From the scenario. Now from there, we shall move on to variables. Variables now. Variables. Now variables, the first one is always the independent variable. Independent variable. Now for this case here, our independent variable is going to be the length of the wire. Length of the wire. Length of the wire. That's going to be our independent variable. Now our dependent variable is going to be ammeter reading. Meter reading I. That is going to be our dependent variable, ammeter reading I. Now from here, we shall have our derived variable, derived variable. Now the derived variable is a variable that we calculate in an experiment using either the independent or the dependent variable. That is called a derivative variable. Now for this case here, we are going to be looking at the control variable. Control variable now, if you look in this experiment here, we have been looking at, we are trying to investigate resistance and current. So look at which factor of resistance, affecting resistance, are we investigating here. We are investigating the length of the wire. So what happens is we must make sure that the list of the factors affecting resistance, in this case, we fix them. But now for this case, you only need to pick like one. So we shall come and say our control variable is going to be temperature. Temperature of the surrounding. Remember, temperature is one of the factors that affect resistance. So since we are investigating or we are varying length of the wire, we need to keep the temperature for the surrounding constant. Someone can even come and say cross-sectional area of the wire, it should be made constant. It should stay constant. Those are our control variables. So when we're done with the variables, we shall come now on list of apparatus. List of apparatus. Now, list of apparatus here, you must mention all the apparatus that you're going to use when you're also giving their purpose in this experiment. So you shall need an ammeter. Then you shall also need the connecting wires. Then you shall also need the one dry cell. We shall need a switch. Then we shall need the bare wire. We shall need the cell holders. I think these are what you give the apparatus, then you also give the purpose it is going to serve in that experiment. Now we move on. After coming up with the list of apparatus, what follows is supposed to be experimental setup. You must have a working setup, experimental setup. Now here, we shall have the figure 1. Figure 1 here, we shall be determining EMF of the dry cell. And that one, we do it by using an open circuit. Actually, we shall also need the voltmeter. We shall also need the voltmeter here, because we shall need it to determine EMF of a dry cell. So we shall have this is going to be our figure one. Figure one. Sorry here, but it must be a complete circuit. So that's going to be our figure one. Then in figure two, we shall have to come up now with our final diagram. Figure two, we shall need now our dry cell in figure two still. We shall need a switch. We shall need a switch. We shall need an ammeter. We shall need an ammeter. Then we shall need our wire here. Then here we shall have our length. Our length here. This is it. Dry cell. Dry cell. This is switch K. These are connecting wires. Connecting wires. Then here, this is going to be our ammeter. Then this is our bare wire. So this is our setup. This is figure two, because I'll be mentioning these figures in our procedures. After coming up with these figures, they must be working diagrams. They have to be working diagrams. They have to be working diagrams. So our experimental setups are done. Remember, it is you as a student to identify all these apparatus. It is you as a student to identify all these apparatus. Now, what follows here, they're supposed to be procedures now. Procedures. Now, procedures here, we shall begin with the first procedure. The first one, we label them using numerical values. The EMF of the dry cell was determined using figure one. The EMF of the dry cell was determined using figure one. So we come up with our EMF, the EMF E. Let me even put E here. Then what follows? The apparatus were then arranged as shown in figure two. Figure two. Now from there we shall come and say, after coming up with this, now what follows here is supposed to be now our length, starting with the distance L equaling to 10 centimeters. Switch K was closed. Switch K was closed, and the ammeter reading I was measured and recorded. Now from there, we shall come and say what follows here is supposed to be procedure 3. Procedure 3 was repeated for L equaling to 20, 30, 40, 50, and 60 centimeters. After doing that now, what follows is going to be the results. The results were tabulated, including values of 1 over I. So now after tabulating the results here, we shall come and say a graph of 1 over I against L was plotted. Then 7, the slope S of the graph was calculated. Then lastly, second last, the resistance K per centimeter was obtained from K is equal to S times E, where E is our EMF and S is our slope. And then the last one is going to be the resistance of the wire was obtained from the expression R is equal to K times 100 centimeters. That is going to be the resistance of the wire. Then when we're doing that one there, we shall come and have our table of results C. Now our table of results here, table of results. So we shall begin by noting down E in the volts. We have our table here. Shall begin with L, the independent variable. Then we move to I. Then shall be moving to this is going to be our table now. Shall begin with L centimeter. Then shall have I in amperes. then shall have 1 over I. It will be per ampere. Those will be the units. So we have 10.0, 20.0, 30.0, 40.0, 50.0, 60.0. Those are going to be that is going to be our table. Now, when the table is done, what follows here is supposed to be data analysis. Data analysis. And whatever you're doing here is like a plan for our practical. So you do the table, leave some space for calculating the slope, calculating the slope, calculating the K, getting the R, and then leave enough space there. Now what follows is supposed to be sources of errors. Sources of errors. This is our table. Then you move on to data analysis, getting the slope, getting K, getting R, all those are supposed to be done in that space. Now, whatever you're doing right now is done before touching the apparatus. Is done before touching the apparatus. So when you start touching the apparatus now, you'll be getting the values and recording the values in your table. Let us now move on to sources of errors. Sources of errors. Now, the first one here is going to be loose contacts. Loose contacts of the wire. Loose contacts. Then from there, you can have parallax errors. When you're observing the ammeter and the voltmeter, you can have some parallax errors. Then you can have some instrumental errors. The one that come with the apparatus, these ammeters and the voltmeters. Then you can have which other error can we talk about here? Maybe if you use long wires, like when you use longer wires, you are increasing resistance. Long wires. Now we come and give the precautions that we have taken. Precautions here. The first one, tightening the what? Tightening the wires. Tightening the contacts. The contacts. Repeating the experiment. And obtain average value. Using short wires. Those are some of the precautions. Then when that one is done, you come and give our conclusion. Remember, conclusion must capture the hypothesis. Conclusion must capture the errors. The conclusion must capture the purpose as you are concluding. Have you been able to achieve the purpose? As you experiment, achieve the purpose, its purpose? If yes, you comment it in the conclusion. So basically, this is how we can answer this item here. But now, as we answer this item here, you can use the same setup here. As we see, you can use this setup here even to determine the internal resistance of the dry cell by simply getting the intercept on the y-axis. Then you come and say that our R is going to equal to C times E. In case the item is about determining the internal resistance of the dry cell, you can come and use this very setup. Thanks for watching my videos. Keep on sharing and subscribing, liking the video. Yeah, I'm still uploading a lot of useful content here in line with the competency-based curriculum. Have a good day.